Have you ever stepped into an elevator, pressed a button, and trusted your life to a metal box without thinking twice? You go up, you go down, smoothly, quietly, and safely. But have you ever stopped to ask, how does an elevator actually work? What keeps it from falling? How does it know which floor to stop at? And what really happens behind those closed doors? Today, we're breaking it all down step by step, in the simplest way possible. By the end of this video, you'll never look at elevators the same way again. At its core, an elevator is a vertical transportation system designed to move people or goods between floors safely and efficiently. Even though they look complex, they rely on a few key principles: balance, controlled motion, safety systems, and smart control logic. Modern elevators are engineering masterpieces, built to be far safer than most people realize. First, let's look at the main components. The box you step into is the elevator car or cabin, reinforced with steel to handle heavy loads. Then there's the counterweight, a heavy block that balances the car. It usually weighs about the same as the car plus half its maximum passenger load. Connecting them are the hoist cables, incredibly strong steel ropes. And I mean multiple ropes, not just one. The electric motor doesn't lift the car directly. Instead, it turns a pulley, also called a sheave, which is a grooved wheel that grips the cables and moves them. To keep everything moving straight and stable, you have guide rails on both sides of the shaft. And finally, the control system, the brain of the elevator that decides where to go and when to stop. Now let us tackle one of the biggest myths, that elevators are just hanging by a single cable ready to snap. That's completely false. Elevators use multiple steel cables, and each one is strong enough to hold the entire elevator on its own. So even if one were to fail, which is extremely rare, the others would hold the car safely. But that's not all. The real secret to how they work so efficiently is the counterweight. The counterweight is one of the most brilliant parts of the design. Instead of lifting the full weight of the car and everyone inside, the motor only needs to move the difference in weight between the car and the counterweight. This saves a massive amount of energy, reduces strain on the motor, and makes the whole ride smoother. When the car goes up, the counterweight goes down. When the car goes down, the counterweight goes up. It's a beautifully simple, perfectly balanced system. So, how does it all come together when you press a button? You press a floor number, and the control system receives the signal. The motor turns the pulley moves the steel cables, and the car moves up or down along its guide rails. The motor carefully controls the speed, acceleration, and deceleration. That's why you don't get jerked around or come to an abrupt stop. It's all calculated for a smooth, comfortable ride. But how do elevators know which floor they're on? They don't guess, they measure. They use a combination of sensors, encoders, and position tracking systems. These devices constantly feed information back to the controller: how fast the car is moving, its exact location in the shaft, and when it's approaching the right floor. As the elevator nears your destination, it slows down with incredible precision and stops within millimeters of being perfectly level with the floor. And what about the doors? They're more complex than you might think. Elevator doors have their own motors, motion sensors, and often, infrared safety beams that create an invisible curtain of light. If anything breaks that beam, your hand, a bag, or even just a slight obstruction, the doors will automatically reopen. This is a key safety feature that prevents injuries. Crucially, the elevator will not move an inch unless the doors are fully closed and locked. This brings us to the layers of safety systems that protect you. Elevators are designed with multiple, redundant backups. First, there's the braking system. If the power fails, powerful mechanical brakes automatically clamp onto the guide rails and bring the car to a secure stop. Then there's the overspeed governor. If the elevator, for any reason, starts moving too fast, this device trips and triggers a separate set of emergency brakes. These are the safety gear, special clamps that lock the car directly onto the guide rails, stopping it cold. And as a final line of defense, at the very bottom of the elevator shaft, there are buffer springs or hydraulic shock absorbers to cushion the car in the absolute worst-case scenario. All these systems working together are why elevators are statistically one of the safest forms of transportation in the world. So what happens during a power failure? Contrary to what you see in movies, elevators don't just plummet. Most modern elevators have battery backups. They'll automatically move to the nearest floor and open the doors to let you out safely. Emergency lighting and ventilation systems also kick in to keep you comfortable. It's also good to know that not all elevators work the same way. The most common are traction elevators, which use cables and counterweights, perfect for mid-rise and high-rise buildings. For shorter buildings, you often find hydraulic elevators. These use a piston and hydraulic fluid to push the car up from below. They're slower but very powerful. A newer type is the machine room-less or MRL elevator. They have a compact motor placed right inside the shaft, which saves space and is more energy efficient, making them popular in modern buildings. The type of elevator is chosen based on the building's height, how it will be used, and energy needs. And today, elevators are getting even smarter. Advanced systems can group passengers going to the same floors together to reduce waiting times and save energy. They can even learn a building's traffic patterns to predict when they'll be needed most. In some large buildings, you don't even press a button inside the car anymore. You select your floor in the lobby, and a central system assigns you the fastest elevator to get you there. Think about it. They carry tons of weight, move hundreds of times a day, rarely fail, and keep people safe for decades, all while operating quietly behind the scenes. Every single ride you take is a symphony of physics, electrical engineering, mechanical precision, and intelligent software working in perfect harmony. So, the next time you step into an elevator, I hope you remember this. You're not just riding in a box. You're inside a perfectly balanced, highly intelligent machine designed with multiple layers of safety, precision, and engineering excellence. And now, you understand exactly how it works. If this explanation made elevators clearer and more fascinating for you, please hit that like button and share this video with someone who loves learning how things work. Let me know in the comments what everyday machine you want me to explain next. And of course, subscribe for more simple, powerful explanations of the world around us. Thanks for watching, and I'll see you in the next video.